Hey everyone, right now we are going to have a look at making links between files. However, before we go there, we need to understand some identifying elements. Now, processes are identified by their process IDs, or commonly called PIDs. Users are identified by their user IDs. Groups are identified by their group IDs. Now, what about files? Now, you may be forgiven if you thought file IDs. That is not true. Files are identified by their index nodes, or commonly called inodes. An inode keeps track about everything about the file except for the name of the file. Now, inodes are file system specific. Now, if you are making use of the XFS file system, which is the default file system for Red Hat Enterprise Linux, it generates inodes of 512 bytes in size. And these inodes are generated dynamically. So as you create the file, the inode is created for that file. Every file has an inode. And the inode keeps track of things like the ownership, the permissions, the date and timestamps, and the actual paths to the data blocks that contains the file's data. The inode does not keep track of the name of the file. Now, the name of the file is the responsibility of the file allocation table. Now, the file allocation table, just to put it simplistically, has the name of the file and the inode that is associated with that particular name. Now, let's go and have a look at my demo-based system. So what I've done over here is that I've run the command xfsinfo against the root of my file system, because the root of my file system uses XFS, and what I want to point out is that we have the inode size of 512 bytes. Now, let's go and put that into play. In the training resources directory, I've got a file called Hello World. Look, there's Hello World. And if we want to get more information about that file, we can do a long listing. Now, if you want to see the inode that is associated with a file, you would use the I option. So all that I'm doing over here is using the command ls-li, and I'm showing you the contents of the directory, and I'm doing a long listing. And what I want to point out over here is that that number, which is dynamically generated, 1827, 8838, that is the inode that is associated with the file called Hello World. Now, there's a certain number that I want to point out right now. Look at that number 1 that I'm highlighting. That is called the link count. What the link count does is that it tells us how many names are associated with that particular inode. That's useful information, right? Nod your head along with me. Yes, it's very useful information. So there's one name that is associated with that particular inode. And if you look at the contents of that Hello World file, it says, hello, RH124 students. Now, to create a link, and the kind of link that we are creating over here is called a hard link. So what you can see is that we would use the command ln, the file that we want to link to, and that is Hello World, and then finally the second argument, that would be the link that we are creating. So ln, Hello World, and we're linking that to Red Hat Learning. Now, if you do a listing in the directory right now, you'll see that, yes, there are 2 files. One is called Hello World. The one is called Red Hat Learning. And if you look at the contents of Hello World, it says hello RH124 students. And the same applies to the Red Hat Learning file. Hello RH124 students. Now, which file did I create first? Now, without you having seen me do that, it would be pretty hard for you to determine that information. Because if you have a look at the output of ls-li, you can certainly see over here that there are 2 files, Hello World and Red Hat Learning. And they have the same inode, right? Now, if they have the same inode, now go back to the whiteboard. If they have the same inode, that means that they would have the same ownership, the same permission, the same date and timestamps, and the same paths to the data blocks for that particular file. So the other thing that I want to point out over here is that very special number, which is the link count. So you can see that the link count over here is set to 2. What this is saying is that there are 2 names that are associated with inode 1827, 8838. Now, let me go and run the date command. And what I want to point out over here is that it is Monday, June the 6th, and it's 3:13 in the afternoon. And what I'm going to do right now is use the touch command against the file called Red Hat Learning. Now, we know what the touch command does, right? So when you use the touch command, and if the file does not exist, it creates a file 0 bytes in size of that name. However, if the file does exist, it updates the date and timestamp to that of the current date and time. Now, if you now have a look at the output of the ls-li command, what you will see right now is that Hello World and Red Hat Learning have an updated timestamp. You can see right now that it is 13 minutes past 3 in the afternoon. Previously, the timestamp was 12 minutes past 3 in the afternoon. Now, let's go and see what happens when we use the rm command to remove Hello World. Now, what's going to happen is that if the link count is not 1, it's simply going to decrease the link count. It's going to remove that name from the inode. So what is happening over here is that because the link count is set to 2, it's going to remove the name Hello World from that inode. So when you look at the output of ls-li right now, inside of the current directory, you will still see that there's a file called Red Hat Learning. And the file Red Hat Learning points to inode 1827-8838. Now remember that these inodes are generated dynamically. So your inodes are going to be different to my inodes. Now let's go and have a look at another use case over here. I'm going to do an ls in the current directory, and what I want to do is link training resources. That's the directory that already exists. I want to link it to a new directory called learning material. And you can see right now that it says hard link is not allowed for the directory. And that is because there are 2 limitations of hard links that I would like you to be mindful of. Hard links can only link files on the same file system. Hard links cannot link directories. So if you do want to use links for directories, and if you do want to link files across file systems, then you need to make use of symbolic links or symlinks. Now, what you can see over here is that we would use the same command, in other words, ln. The option, however, that we would use is the s option. So we are saying, let's go ahead and create a symbolic link, and the last argument is the link that you are creating. So we're going to be linking training resources to learning material. Now, if you have a look at the inode associated with, and this is an interesting one. So we are using ls-l to do a long listing, d to transact against the directory, not the contents of the directory, but the directory itself, I for the inode. You will see right now that learning material and training resources have the same inode, 1827-8818. However, if you do an ls-li and you don't use the D option, what you can see over here, and let me highlight this line, you can see that a very special file is being created, and you can see it's learning material. And look at how it's colorized differently. It's colorized differently to indicate that it's a special file. And that special file called learning material points to training resources, and it has its own inode. Now, that is how symbolic links work. However, it does come with a disadvantage. If you delete the directory that the symbolic link points to, or the file that the symbolic link points to, you end up with what is called a broken link. And again, look at how that is colorized. You can see over here, learning material points to training resources, and it does not exist. So let's have a look at a couple of use cases over here. If you have a look inside of the current directory, I've got a file called my shared lib version 1. So let's just say that you have an application and the application is looking for a library, and the name of the library that the application expects is my shared lib. Now, you currently have version 1 installed. So what you could do is that you could create a symbolic link. And what this means right now is that with this command, you are linking the name my shared lib version 1 to a file called my shared lib. And that is the file that the application expects. So your application is working very happily. However, there's an updated version of the library because perhaps there's a bug. Maybe there's an enhancement that you would like to take advantage of. So what you could do right now is that you could install the updated version. So if you have a look at the file my shared lib, currently it points to my shared lib version 1. Now, I've got another file over here called my shared lib version 2. There it is. And all that I'm going to do right now is that I'm going to go ahead and delete the link using the rm command. So rm my shared lib, and then I simply go and recreate the symbolic link. And what I'm doing over here is that I'm linking the name my shared lib to the existing file, the updated file, the file that gives us the new features called my shared lib version 2. And now the application keeps on working. And the application is able to keep on working because it has access to the shared library that it expects. And the name that is expected is my shared lib. Here's another use case. Let's just say that you've got this really complicated directory structure for your customers' website data. So I've got /vhosts /example incorporated /apps.example.com /HTML. Now, for your users, for your customers, it may be rather difficult for them to navigate to that path. You want to keep it simple, right? Complexity kills productivity. So what you could do is that you could simplify access for them. Now have a look at this command over here. ln-s, we are linking vhosts, example link, apps.example.com, HTML, and we're simply putting that inside of /home student HTML. And what that means is that the customer, in other words, the student user, simply goes to their home directory, they change into the directory HTML, and of course they can work inside of that directory, which is way simpler. So if you have a look at the listing of the home student directory over here, you can see HTML and what it points to. Links are awesome, and you should make use of them. In fact, your operating system uses links rather extensively. Now, I'm sure that you want to get your hands dirty, so head on over to the next video, and I'll meet you there for the guided exercise.